My name is Ed Armstrong, and today I'll be presenting to you Git. So Git is the most widely used revision control system currently in use. It's an open source project that's been used for maintaining the Linux kernel since 2005. It has become the de facto standard in revision control software as it features a distributed architecture that maintains your full repository in multiple locations. The Git workflow excels at flexibility. It works with both single developer projects on one machine and multiple developer projects across a variety of machines. Before we continue today, I'd just like to point out that this is part of a effort that we have on our Moodle site at training.sharcnet.ca, where I will be putting up, there's a forum for you to ask questions, and I'll be putting up follow-up videos because we can't really get the complete encompassment of Git in a 45-minute video. This video, as mentioned before, is also posted at youtube.sharcnet.ca. So what is revision control? Revision control, also known as version control or source control, is a software package that was originally designed for maintaining source code. Changes to your source code or your project assets or anything else that is involved in developing your software can be tracked and managed with revision control. Some of the things you can do with it are you can undo the changes to your files. So much like you do on a Word editor or on a text editor, you can go back to previous versions of a file that you've made. You can work on multiple branches simultaneously. So that's to say that, say you want to work on a hotfix for something on your code, or you want to work on a new feature. You don't have to pollute your main branch with your new code. You can work on a separate branch and merge it in later. It helps you manage multiple developers. By using a central repository, you can push and pull different revisions from different developers and manage them more easily. And of course, the automatic backup of your code base. It makes it very easy to move your code base from one computer to another and back it up automatically with a single line. So revision control, you're going to start with an empty root repository. From here, you can add files and make changes to this repository. You can make multiple changes. You can do piecemeal changes, and it will remember the previous commit. So each node, each commit that you do remembers the changes that came before it. At any time, you can tag a commit so that Git takes a snapshot of a certain point of your repository. This allows you to check out specific versions of your software. Once you've made a tag, you can continue making more changes, and your user can check out that tag without having to worry about what changes you have made since you tagged it. Of course, you can continue making changes past that. You can undo changes that you've done. And as we mentioned, you can branch and you can make more than one tag. So we're going to first cover the core of Git. And that involves the 5 commands, init, add, commit, log, and status. So when you use init, you're going to create a new repository on your local machine. The add and commit commands are the core commands you'll use most often. They are central to using Git. The log and status are the 2 commands that allow you to view the state of your repository. Now, all commands that you use will be prefixed by the Git executable, and then you'll use the command name and any flags or options that come afterwards. We're going to first cover a little bit of terminology that Git uses while explaining or in the usage of Git. So the working directory, that is the directory where your files that you are familiar with are kept. You make a change, when you save a file, you copy it, it's your working directory, it's the directory on your laptop. The staging area is kind of a in-between area that says these are the changes that I want, that I've made. So it's an intermediary between the Git repository and your working directory. And you'll store the changes before you commit them there. And then the Git repository itself is where you store the files that have been committed, that have been handed over to Git, and to track them. Here, the history of changes that you've made are kept, And each one has a unique key known as an SHA key as attached to it. And you can use this to refer to previous commits. So how we're going to work, or how Git works in a kind of macro way, is you have a working directory, and this is your files on your computer. You'll use add one or more times to add these changes every time you change a file to the staging area. Once you're satisfied with your changes and you've marked the changes you want to save, you'll use commit to move it to the Git repository. We'll now run through in a bit of detail what each of the commands do before going on to a demonstration. This command, the git init command, creates an empty Git repository. It is basically a .git directory within your working directory. It has subdirectories for objects, references, tags, and so forth, and it's where all the information is actually stored. An initial head file is created in this .git directory that references the last version of the repository that has either been committed or checked out. It's considered the current state or the last state of your repository. Running git init in an existing directory that has files already there won't harm them. It's okay. It doesn't interfere with files that exist. You can also safely run git init in an existing repository. So you can run git init multiple times, and you'll sometimes do this in order to set certain options, but it won't change the state of your repository. It will not overwrite things that are already there. I've included an example bear flag here because you'll see this the odd time if you want to create a repository that's more of a central repository as opposed to a working repository. The git add command takes the path name or a single file, and it uses it to mark files that need to be committed or are going to be committed. You can also use @dot for the current directory or @star for all the files in the directory. Note that when you add a directory itself, it's recursive. So it'll add everything within that directory and so on and so forth. Now git add works in concert with git commit. And this git commits can be captured and built up locally, allowing you to perform multiple adds for each commit. The commands git add, git status, and git commit are all used in combination to save a snapshot of the Git project's current state. The git add and git commit commands are fundamental to the Git workflow. These are the two commands that every user needs to understand regardless. The primary function of the git add command is to let Git know that a file has been changed, while the purpose of the git commit command is to store all of the changes or all of the adds in a single snapshot. I've included some of the most common flags here for your git commit. The -a will mean you'll add everything that has been previously added, you'll add it again. And this is a shortcut for when you just change files as opposed to adding new files. The -m flag is for a quick message. If you don't include the -m flag, it's going to pop up your text editor and ask you to put in a message. And of course, you can combine flags as well. To read and review all of the changes that have been made to your Git repo, we're going to use the git log and git status commands. And there are three common flags for the log command that makes things a lot more readable. The one line will condense your log into a single line and give you just the most critical information. The all flag will show you all branches or all nodes and all branches in your repository as opposed to just your current working branch. And the graph will make some nice little lines on your in your console that will show you where the parent nodes are for each commit. And git status shows you the current state of your Git tree. And the status displays the differences between the index file and the current head commit, as well as the differences between the working tree and the head and paths in the working tree that are not tracked by Git. It generally gives you a bit of information on what's going on when. We're going to start by talking about the head node. So the head node, or the very top of your repository, you can think of it as the last committed version of your repository, but it's also the last checked out, the last thing you looked at, but it's usually the last change you committed. So in this example, if we add everything in the directory and we commit with the message initial commit, the log will show a head, which means that the head node is currently pointing at the top of the master branch. The master branch is the branch that is created by default in Git. The log also shows you the message that you gave, initial commit, and a shortened version of your SHA hash value, which we of course mirrored down here. When we add another file, so we'll add source.c to the repository, we add another commit with a new message. What the log will look like is the head is still pointing at the master branch, but the master now points at a different hash value with a different message. So this is showing you how the tree is building up on top of itself. If you further commit, you can copy, which will also, you still have to add after you do a copy, and then you can commit an added file, do the log, and again, we're just building up one node on top of the other. So the concept here is there's a head node that points to a branch, and the branch is simply a pointer to the top of, to some commit. And that's what we're adding to, and each one of those has a parent. Now Git, like most revision control systems, allows you to branch and merge your workflow. Branching means you diverge from the master development branch and continue working on files in isolation. Git branches are extremely lightweight, which allows you to switch easily between them and back again. Here we start with an initial working directory that we will make a change to. When we make a different modification separate from the first, we can branch it to keep it separate. You can then make changes to your main branch, adding more modifications, and then switch back to your other branch and continue working there. When you're happy with the state of your project, you can merge the two branches together to make one head. So the situation we'll find ourselves in is we want to make edits to some files, but keep them isolated until we are satisfied with them. We're going to use git branch, git checkout, and git merge. We'll create a new branch and update it while continuing to update the master branch as well. In the end, we'll merge both branches together. So you'll use git add. You can add 3 files at once. You can put in multiples. So we've added hello world, makefile, and assets.txt and committed it. So our head is currently pointing at the master branch. Our repository consists of a single node. We will now go git branch testing. That's the command you'll use. The command is branch, and of course we name the branch testing. And that will simply create a new pointer to the same node that your head is currently pointed at. So it's right now it is the same as master. We haven't checked out the testing branch. So when we add a library.c file and we commit it, it adds to the master branch. And now the testing and the master have diverged. So testing points at what it was pointing at when it was created, and master has moved on to our most recent commit. If we take a look at the contents of the working directory, you'll see we have the make file, the assets, the hello world, and the library file. But when we check out testing and we do a list, the pointer moves to the testing commit. And if we do an ls, you'll see that the working directory has now changed. It is no longer have the library file, which was added while we were on master. It now has make file, assets, and hello world, which is what we had before we diverged the master and the testing branch. So note, git checkout, the name of the branch you want to check out, will bring your repository to what you were at when you created that branch, or when you made the last commit while on that branch, as we'll see in a moment. Here, now that we're on the testing branch, we're going to use our friend add again. We're going to add a testing.c file and commit it. If we take a look at the log and we use the one line in all flags, you'll see a couple of things new here. You've got the messages that we had before, added library file and master. So the master branch is currently sitting on this node. Because it was created first, it's below this commit. However, this commit is where the testing branch is set. And because that was our last checkout, the head is pointing at it. And now it's become more obvious when we commit this change, it becomes more obvious why they're called branches, because now you can see how they've diverged from each other. Now we'll use git checkout again to move back to the master branch. We've used checkout again. We've used the name of the branch, which is master. And if we take a look at the contents of the working directory, library.c is back because we made that while we were on the master branch. However, the testing file is now gone because we made that while we were on the testing branch. If you take a look at our log file, you'll see that testing is still at the top because it was the most recent commit. However, head is now pointing at master. And that is because that was our last checkout. And that's where our new changes will be committed. If we're happy with our testing branch, we're going to use the merge command and git merge testing. You will have to be in the branch that you want to merge into. So we've checked out master, and we are merging from is the name we give it. So git merge testing will pull testing into master. And when we use that command, it tells us the default strategy and some file changes, some information about what happened. And what happens visually, if you take a look at the list, you'll see that now the list of the master has a library and the testing files. That's because they merged them together. And because there is no library in testing and there is no testing in the, there is no library.c file in the testing branch, and there's no testing.c file in the master branch, we didn't get any conflicts. Now let's have a little look at the graph of what happens at the log. So if we use the git log one line and all, but we're going to add the graph flag. And this gives you these lines and stars and shows you the direction and the hierarchy of your repository. So you've got the init, then we diverged. So the first thing we did was initialize the repository, added the library file, and then we added the testing file, but that was diverged on a branch. And then we merge branch testing. Now the head is pointing at master and the master node because that's what we were in when we did the merge. However, you'll note that the testing branch is still where it was before, and you can check that out and continue working and branch off further. However, as is typically, you will want to just get rid of that branch. You've used that branch, it's done its job. Now you need to delete it, and you'll use the -d flag with branch. And if you take a look at the log again, you will see the head is still pointing at master, but the testing branch itself is gone. You can, however, still check out that commit. Just because you no longer have a branch pointing at it doesn't mean you can't access it anymore. So when you use the git checkout command, instead of just using branch, you can put in the SHA hash value. You only need the first couple of characters because it can differentiate what they are. And what this will do is it will put you into what's known as a detached head state. You can look around, you can make experimental changes and commit them to your repository, and you can discard the commits that you make in the state without impacting the other branches or performing another checkout. However, if you end up that you want to make if you've made some changes that you want to keep on the detached head state, you'll have to create a new branch to retain the commits that you created. You can do this now while you're working with it, or by using the -b command with the checkout again. And the instructions for that are actually all in status while you're working in the repository. Introduced in the previous section, merging is Git's way of bringing diverged branches back together into a single branch. In this case, Git will take two commits, usually branch pointers, which in this case are master and target, and combines the changes found in each one. It will create a new commit with the unique situation of that commit having two parent nodes. Git will then try to combine all the changes found within each source into a new node. Any changes that can't be combined are considered to be in conflict and will require user intervention. So before we move on to a demonstration of some of these merge conflicts, there's a merge checklist. You kind of have, first thing you want to do is you want to check out the branch that you want to merge into. Use git status to ensure that head is pointing at the destination branch. Fetch any remote changes. We'll talk about that in the next section. And then execute git merge target, providing the name of the source branch. One form of merge is known as the fast forward. If you have two non-divergent paths from a source commit to a destination commit, it's possible to perform what is known as a fast forward merge. So we had a master branch, and then we provided some changes to a branch called target. So we checked out target and we added files, or we modified files, but we didn't do anything to the master branch after we created the target branch. And this will be typical of the case if you do a hot fix. You want to do it isolated, but you're not going to touch your master branch until you get the bug fixed. So Git will simply integrate the histories of both branches by moving the master branch forward to match the target branch, known as a fast forward commit. And it's the most straightforward commit. However, there are two conflicts that can occur. So Git fails to merge due to both branches having edits on the same file. So that means you have a file in one branch that you've changed, and the same file that exists in another branch with the same name, you've also done edits to. This is the most common conflict. The other conflict that can occur is Git fails to start due to changes in the working directory or staging area. The difference with this one is you haven't committed the changes to a branch, and Git would overwrite changes that haven't been saved. So Git won't start the commit. So the situation we'll be going through is you have two branches that you want to merge. Each branch has made edits to the same file. We will use git branch, git checkout, and git merge to solve this problem. We solve the conflict and recommit the merge. I'm going to do this on the command line, but in order to make it a little bit easier to follow along, I'm going to explain what I'm going to do first. I'm going to create a new repository. I'm going to add a single file to the default master branch. I'll create and check out a target branch and append a line to the file. So it's going to be the same file that exists in both branches. I will then check out the master branch again and append another line to it, and then attempt to merge. Because I've appended a line in both the master branch and the target branch, this will create a conflict. How do we fix it? Well, there'll be three ways to fix it. We'll manually edit the file. You can abort the merge and just continue working with two branches. Or you can commit by specifying which branch to keep, either the target or the destination branch. But when you manually edit the file, you're going to find some information in there, I guess would be the best way to put it. It's going to combine, Git will combine the changes found in each file or each version of the file and present them to you. Anything before these arrows and this head indicator means there's no conflicts. That's found the same in both files. Everything between the head and these equal signs means that it's found on the destination branch, typically the master branch. Everything between the equal signs and the target, this is the name of the branch that we merged with, will be the changes found there. And everything below that, again, is no conflicts. So the first demonstration I'm going to do is just to create a repository. So we're going to go git init my repo. And that initializes a new empty Git repository, and it tells you where it was, and it was made here in this directory, and it's called my repo. You'll take note of the .git. If we go in and we look at my repo, while it looks empty, if we take further look, we'll see the hidden .git directory. We'll just take a quick peek in there. And there's several subdirectories in there, the most important of which will be branches. You recognize that term. The head node, this will store the pointer to what the current last commit was, and objects. And that is actually where Git stores copies of all the files that you've made. We'll look at Git status. It's an empty repository. There's no commits yet, nothing to see. And log. Again, your current branch master doesn't have any commits. So let's create a new file, and we're just going to so we now have a file in our working directory called hello-world.c. We are going to use git add, specify the file name, and we'll go take a look at git status before we do anything else. So it tells us we're on branch master. We haven't done any commits yet, but there are changes to be committed. So this means they have been staged with add, but not committed. Some information there on how to unstage and what your new file named is. We will now go with git commit -m for message, and we'll just call it the initial commit. If we take a look at status now, git status, we're on the master branch, nothing to commit because we've committed everything in, and we'll take a look at the log. So this is the raw log, and there's a lot of information going on there that you don't really need. You know you committed it, you know the date, and this is the full message. And this is what a full hash looks like. So we're going to use git log with one line, and that just condenses it down to the critical information, shortened of the hash, where your head is pointing, and the message. Git status, master branch, nothing to commit. And we are going to create another file called hello-world.h. We will use the status again. And now you'll see that we have an untracked file because we haven't added it to the repository yet. And it tells us we have to add it. And the file that hasn't been added is hello-world.h. If we add a line to hello-world.c, and we go with status, we get some more information. So you're still on branch master. Changes not staged for commit, hello-world.c. So we've modified the file. So it's a file that Git knows about that we've made a change to. And it's kind of a warning that we haven't actually added it. And untracked, hello-world.h. So we're going to go git add dot to add everything. Git commit. Now you'll see that we've popped up Vim. And that's because we didn't specify the -m flag. And this is going to be, we've added a header file. And we'll put a second line here, modified source file. We will write and quit. We go git log one line. And you'll see just the top of the file. This is just the top of the message that we just put in. And we've got a second commit. Now we're going to talk about merge. So we're just going to make the repo from scratch again. See if I can type my repo. So we'll initialize a new repository, and we'll call it merge demo. We'll call into it. We'll make a new file. So we're going to just make a text file. This is the first line. And this is going to go into the merge dot, we'll just call it merge.text. Got that, it's got it in there. We're going to add it. We'll use the star this time. Git commit, initial commit. Oh, commit has two M's. And we'll just take a look at the status, just make sure everything is what we want it to be. Now we're going to create and check out a new branch. So we're going to use git checkout with the -b flag, which we haven't seen yet. It's a shortcut to making a branch and checking it out. And we're going to call the new branch target. So we're going to create and check out the branch target. We're going to look at our status now. And you'll notice it used to be on branch master. We are now on branch target. Nothing to commit because nothing has changed. Merge.text, but we're going to modify the merge.text file. Echo this line added by target. And I've chosen these lines deliberately so when we see the merge file together, we'll know where they came from. We will add it, and we will commit it. So we know the target branch changed the file. Get log one line. And you can see now, as we pointed out on the slides, that the head is pointing to the target branch and the master branch exists separately. Now to move to the master branch, we're just going to use git checkout master. And you'll see we've moved to the master branch and the head is now pointing at the master. But we don't see the target there, and that's because we forgot the dash all flag. When you're on a branch, particularly when you're on the master branch, it's not going to show you all of the other branches. So the head is pointing at the master, which was created first, so it's below the target, and the target branch changed a file. Now we're going to do another change, but we're going to do this in the master branch, separate from the target. So we'll just take a look at the file first. And you'll notice it's only got the original line, and that's because the change was made in a branch. We'll echo this line added by master. Goes into merge, cat merge, take a look at it. It's being added. We're going to add and commit it. We're going to use the shortcut this time so that with that dash I, sorry, the dash A flag means we're just going to add all changed files that we've added previously. And this is just a shortcut for, because most people just do git add dot. So master branch change file. Learn how to spell branch. Git log so we can see what everything looks like, and all. And we're going to take a look at the graph flag this time so we can see the nice little graphical representation. So we've got the initial commit. Now you can see that we've diverged by the graph and that the target branch changed a file and the master branch changed a file. Look at the merge file and we've got two lines, but only the one from the master. So now we are going to create our conflict. We are going to make sure we're going to look at get status to make sure we are on the destination branch, so we're on master. We'll be pulling the changes into this one. Git merge target, the name of the branch we want to pull from. Auto merging and conflict. So the conflict in merge.txt, automatic merge failed, fix the conflicts, then commit the result. So let's take a look, and we're going to take a look at the status first. And it gives us some information. It tells us this is get status, kind of lets you know what state your repository is in. And our state is in an unmerged path state. We have to fix conflicts and run git commit. We can use git merge abort to abort the merge, which we'll do in our next demonstration. And it tells us what the paths are. So we've modified, both have modified merge.txt. So we have to use git add file to mark the resolution and then commit. So let's do that. So we will modify or take a look at the merge.txt file. And you'll see now we've got all this gobbledygook. The arrows, between the arrows and the equal sign is everything that was added by master. You'll recognize that. And everything between the equal signs and target was everything that was added by target. Now, you could do whatever you want. Now, we can modify this file as we see fit. And we are actually just going to delete the stuff that they've added, and we're going to keep both lines. You don't have to. You can keep one or the other. Just for the sake of argument, we'll keep both. We write it. We have to add the file again, git add merge.txt, and we're going to git commit, and we're going to put a little message in here saying we fixed our merge conflict. We'll look at the file, cat merge. Oh, it's now everything together. And git status, which should be good. And git log, one line, all, and branch. And I forgot a dash on all. What did I do? Oh, graph, not branch, sorry. graph to show branches. We've got our initial commit, our master branch, our target branch, and then the merge. You can see them coming together, fixed our merge conflict. The head is currently pointing at the master because that was the branch we were in when we performed the merge, and the target branch still exists. We will get branch minus D. Actually, I want to show you one command first. Get branch will show you the name of all your branches. Get branch minus V shows you more information. So it shows you the last hash value and the last message for those branches. And now we're going to go get branch minus D target. Deleted branch target. We'll take a look at the graph now. You'll note that the target branch node is still there. We've just removed the pointer to it. And that's all branches are. They are just pointers to commits. We're going to move on to the next merge conflict. So let's remove that directory. And I've got a little script here that just sets up that directory for me. It's going to be all the stuff we did for the first time. We're just going to do it again. And now we've got a merge demo directory. And the status should be good. Nothing here to commit. And we'll just take a look at the log so you know where we're sitting. So this is the state of the repository right before we did the merge. So the target branch has changed the file, the master branch has changed the file, and we're currently pointing to the master branch. Merge.txt will look familiar. It's the same setup we had before. Now, the difference we're going to do this time is we're going to abort. So we're going to get merge target. Again, learn to spell merge. Conflict. Merge conflict in merge.txt. Automatic merge failed. This looks very familiar. Get status. We can see that both are modified merge. And what we're going to pay attention to is use merge -- abort to abort the merge. So get merge abort. And that simply says we did a merge. We didn't mean to. We're going to ask the guy at the next desk what went wrong. Let's just abort the merge. So let's take a look at status. Nothing to commit. Looks like a good repository, good clean repository. Git log, one line, all, and graph. And it's one line, not online. And it looks exactly the same as it was before we committed the merge or attempted the merge. And that's the abort. And that's just kind of the, I made a mistake. Let's stop doing that. Now, the third part is we are going to specify what changes we want to make. So let's create a git init merge demo, call directory merge demo. And we are going to, sorry, the third demonstration isn't specifying. The third demonstration is going to create a conflict on the working directory with the repository, the second type of conflict. So we've got an empty repository, and I'm just going to make a file here, echo I am a teapot, and we'll put that into teapot.txt. We'll add it, add dot, git commit, initial. Status, just to show you what it looks like, git log, and it's just that one commit. We are going to get a branch. So whereas before we did get checkout -b, you can use get branch target. And if we take a look at branch, this will just make a new branch called target, but won't actually check it out, and we'll still be on master, and we must manually check out the target branch. So there's often multiple ways to do the same thing. Get status, where are we? Make sure we are where we think we are, on branch target. We are going to echo short and stout. Hope I'm not violating any copyrights. To teapot.txt. We are going to commit this, git commit -am. We can use A because the repository already knows about the file. And it's just the second verse. Take a look at it, git status, everything's good. And we'll go back to master, git checkout, master, cat teapot. That line that we just put in is not there because it's on a branch. Now, we are going to, this is where we differ from the original conflict, and this is where this conflict is a conflict with the working directory. We are going to add echo, this is my handle, and this would be the case where you forgot to merge branches before you made more changes. We're going to add that to teapot.txt. Now, we're not going to commit that, and we're not going to add it. We're just going to merge now. Git merge target. Updating your local changes. So this is the error. Your local changes to the following files have been overwritten by the merge, would be overwritten by the merge teapot.txt. So it's telling you that you have to commit your changes or stash them before you perform the merge, and it aborts. So it hasn't even started the merge this time. What we are going to do, we say, oh, we made a mistake. We are going to use the git checkout command with these dashes, which we'll explain momentarily. But what this does is it will check out teapot.txt file. If we take a look at teapot.txt, oh, now it looks like it did. Sorry, I meant to cat teapot.txt. It looked like it did before we made our little change up here. So we're going to merge first, git merge target. And now it does a normal merge because the changes were undone by the checkout command. And then we would make our changes as before. Now we're going to talk about git remotes. So a remote is a term which refers to a separate directory with a shared or linked history. They are often stored on servers dedicated for this purpose, such as the commercial sites SourceForge and GitLab, also GitHub, which we'll be using for today's demonstration. And for those who are interested, we do host our own Git repository at git.sharcnet.ca for any Sharcnet members. So the workflow when working with remotes generally goes as follows. You have and you have a remote repository. You will use the git command clone to clone the project to your local computer. You'll then create new content, you'll add files, you'll edit files as you see fit, and you'll commit those locally. And these are going on in your computer, not the remote repo. And you can do this multiple times. You can do multiple file adds, changes, commits, branches, and merges as you see fit. And when you're happy with the changes that you've made to your repository, you're going to push them to your remote repository. You can then continue this by using the git pull command instead of the git clone, and this will pull changes and make your repository up to date with the remote one. Now, a remote repository doesn't have to exist on a centralized server. It simply refers to a copy of your repository that you will push and pull changes from. So you can have it on a centralized server. It can be your coworker's computer or a USB key. It can be a different computer of yours, your laptop or your work computer. It can even be a different file on the same computer. All it refers to is something that is linked with your repository. So the first thing we're going to do is we're going to go to github.com and we're going to create a new repository. And we're going to see this file when we get there. And there's a lot of information here, but for now, because we're using clone, we're only interested in one thing. And that is this address up top, the git@github.com, your username, and the name of your repository. We're going to use the command clone in this format to clone the repository from GitHub to our local laptop. What will happen is we'll use git clone and it will clone the empty repository. So this is the same as using Init on your local repo, except that it's going to set up all the remotes for you. You'll add stuff and you'll do git commit as seen here. And then you'll push those changes back to GitHub using git push. Then along comes coworker who wants a copy of your repository. Now you're not going to send it to him from your computer. You're going to send him the link to your GitHub or give him permission to access your GitHub. And he will do a clone command by using git clone at the same address that you did. And he will now have a copy of the repository that is linked in the same way yours is. He can make changes to his, and he doesn't have to send them directly to you. He can send them back to GitHub, where you can either accept them or reject them, and then pull them yourself back to your local computer. And that is generally the workflow for a shared repository. There are some commands that we haven't seen that you're going to use for remote. And the most important three are clone, pull, and push. Git clone gets a copy of an existing repository, creates a new directory on your computer, initializes Git within that, and pulls down all the data for that repo and checks out the head of the remote repository. Now you can do these things piecemeal if you like, but in this case, this just puts all the commands together. Git pull performs a fetch on the remote repository and attempts to merge that remote branch into your current working branch. Not included here is the git fetch command, which is, again, it's just a smaller chunk of pull. It just pulls the actual information down. It doesn't perform the merge. Git push will update a remote branch using your local branches. So it updates the remote with the commits that you have performed in your local. If another push has occurred at some time between your fetch and your push will be rejected. Your repository has to be up to date with the remote one. There is also the git remote by itself will list the remotes that you have. You'll often use it with git remote -v, which will list all the remotes that the repository is aware of and show you the URLs for them. Git remote add. So this is clone will use the git remote add to add the URL automatically, but you can do it yourself by including the name that you want to refer to it to, by default origin, and the URL it points at. Show just shows some information on that remote. Rename. So if you want to name the remote something else that means more to you, you can use rename. I often use it to rename it to GitHub or to rename it to Sharcnet, depending on which repository I'm pushing to. You can remove a remote, and then of course the fetch command, which is part of the piece of pull that pull uses. Now we're going to go for a demonstration before we move forward. So here we are, we've logged into GitHub. Now, one thing on GitHub you want to take a look at before you continue is you can go in and take a look at your settings, and you can add SSH keys. And what that will allow you to do is that you need to enable SSH keys to make for seamless pushing and pulling from GitHub. That way you don't have to enter your password and your username each time. Highly recommend it. All demonstrations today are going to be done with SSH keys. So we're going to click on new, and we get to name our repository. So what are we going to name it? We're going to name it demo repo. Give it a description. I am a repo. Now GitHub now allows you to have public or private repositories. Public, anyone can see it and they can check it out. They can't push to it. You still have to give them specific permissions. Private means that you can specify who gets to see it. Git will be nice and add, these are the typical files that you want to add to your repo. We're not going to today because I want an empty repo. So I'm going to click create. It creates the repository. It's going to zoom out so you can see the whole screen here. And there's some information on how to move forward. If you have, so you create a new repository on the command line. So you can create the repository and you can set the remote origin manually. Or if you have files that you want to, or you see you have a repository already on your local computer, you can just add this remote to it and push your changes to GitHub. But since we're cloning this and we're cloning as an empty directory, we're just going to copy that address and use it on the command line. So we will go git clone and the address we had. Now, because my SSH keys are set up, Git knows who I am, and I don't have to enter my username and password. And it gives us a little warning. We have a cloned an empty repository, and we did that deliberately, so it's okay. We now have a repository called a demo repo. We will call into demo repo and take a look at it, and it's going to look like an empty repository. Let's just prove that to you. Branch master, no commits yet, and git log, nothing there. So let's take a look at the git remotes. So remote origin. Origin is the name by default given to a remote, but that doesn't mean too much to us. So we're going to use remote-v. Oh, so now we see this is the familiar address that we used to clone it. And all this is telling us it's called origin, and anytime we perform a fetch, which is part of the pull command, it will pull from this address. Anytime we pull from push, we can push to this address. And you can have those. You can change those as you see fit, and you can also have multiple remotes. So we are going to add a file to our remote, or to our, sorry, not our remote, our repository. I go, I'm a file to file.txt. It's in our working directory. Oops, forgot my little arrows. There we go. So now we have file.txt, and we're going to add that to our local repository. Git add dot, git commit, -m, initial commit. Okay. Now we're going to use git push. It's simply that. And because everything is set up by the clone, this is going to push all of our changes to GitHub, who we are, and what the repo is. And if we go take a look at this and we hit refresh on our screen, you'll notice that our file.txt is now on GitHub. You can click on it. Oh, I'm a file. Yes, I am. Let's move back to our command line. We are going to take a look at git. We are going to git checkout hotfix. So we're going to create a branch. Git checkout hotfix. Forgot the -b. So git checkout -b means create the branch, call it hotfix, check it out. We have now created and switched to hotfix. We are going to add a file called hotfix.file. It's empty, but it's added. Git add dot, git commit. Sorry about that. My clipboard just fell over again. We've added. Now we will commit -m added hotfix. So naively, we're just going to go git push. Oh, something has happened. The current branch hotfix has no upstream branch. To push the current branch and set the remote as upstream, use git push, flag set upstream, name of our repository or remote repository, and the name of our branch. So what is this telling us? It says that the branch doesn't exist on GitHub yet. So we have to create it, and we can create it by setting upstream the name of the repository and the name of the branch we want to set. So let's take a look at the branch command as a kind of sideline. You can see there's a hotfix, and you can see there's a master. This is nothing new. Git branch -v is all that. So we're going to go let's get that command back here. Git push, set upstream, hotfix, enumerating objects, counting objects, and so on and so forth. Create a pull for a pull request, so on and so forth. And hotfix is a new branch. So this is what we're really interested in. Is it's created a new hotfix branch on GitHub. Now, if we take hotfix's recent pushes, if we take a look at the branches under here, oh, there's a hotfix file. And you'll notice, of course, that there's a hotfix and file under the hotfix branch. There is no hotfix.file under the master branch, and that's because we haven't merged them. We will go git branch again, git branch -a for all. And let's take a look at what happened here. So the -a flags means show all branches, and that includes remote branches. So your repository will store pointers to remote branches, branches on remote repositories. We have a better way of putting it. we've got our hotfix, we've got our master, but they also have a hotfix and a master. And this was created by that last push we just did. So we're going to return to this directory. And we are going to create a clone of the GitHub repository. And we're just going to put it into a different directory on our computer. So git clone, the address again. Oh, the address isn't there anymore. Let's type it in. We will actually, if you want to find the address on here, because oftentimes you can never remember how they're exactly worded. If you look under code, this button here, and you look under SSH, you'll have the address we saw at the beginning. And it says you have to use a password protected SSH key to get it. So we'll just copy that again. We'll get clone. Now we're going to put in the name of it because we already have a demo repo file on here. We're going to go demo repo 2. And now we have two repositories, demo repo and demo repo 2. While they're different repositories on our local machine, they are linked to the same remote repository. So let's go take a look at demo repo 2. And there's the file.txt. Now, what is interesting is if we go git branch, you'll notice there's only the master branch here. But if you go git branch -a, there is a remote hotfix branch. So we want to take a look at the remote hotfix branch. We will go git branch and we can just go hotfix, even though it's not listed there. And it will now have created a local hotfix branch and that we can check out and look at. So at any stage, you may want to undo something. And here we're going to review a few of the basic tools to undo changes that you've made. And I stress you should be careful because you can't always revert some of these undos. This is one of the areas in Git where you may lose some work if you do it wrong. So the first situation is you have edited files and saved the changes, but you haven't committed them. Now you change your mind, you no longer want to keep the changes, you're going to use the checkout command. Git will alter the files in the working directory to match the last commit. So it says when we look at the status, when we have not committed, but we've staged files, it tells you to use the checkout with this --. And this is very similar to the git checkout branch. What happens is the double dash in Git means different things in different commands, but in general, it separates the options from the parameters. And we use it to force checkout to read a file. If you have a file called master, you would use a --, it would know it's a file and not the branch. And what happens when we do git checkout hello world.c after vim hello world.c is it will overwrite the working directory with what exists in your repository. And this is important to note. It's important to understand that git checkout is a dangerous command. Any local changes you've made are gone. Git replaces the file with the most recently committed version. Don't ever use this command unless you absolutely know that you don't want those unsaved local changes. And that's because you haven't actually committed the changes you've made that you're overwriting. A second situation, you change multiple files and want to commit them in two separate commits. You accidentally use git add *, it becomes almost automatic after a while. So you want to remove them from the current commit, but keep the changes. And you're going to use git reset head in the name of the file. And it is used to unstage the files in the current commit. So in this case, we modify hello world.c and hello world.h, and we've added them. If you take a look at the status, it gives you a hint as to what to do. Git reset head, the name of the file. And what this does is because they are staged, it's not a big deal. What will happen is simply unstage it. No changes have been overwritten and no update to your repository is made. You use git reset head, hello world.c, and because we specified hello world.c, hello world.h is still staged and will be used in the next commit. So reset on branch master, the branch is up to date with origin master. This is the status during, you can see git reset head file to unstage. This just shows you what it looks like after we've used reset. You can still reset the other one, and this one is no longer staged for commit. The last undo is amend. So the situation is you've committed your changes too early and you want to add to your commit. And you're going to use commit again with the --amend flag. and it will replace the previous commit with your current second commit, and it treats it as a whole new commit. This is most often used so you don't pollute your Git repository with small changes. Say you forgot to rename a file or you forgot one simple change. You'll simply use amend to it, and it will treat it like the last change, or treat it like the last commit. So in this case, we vim hello world.c, and we add it to the staging area. Then we commit it and say modified.c file and log. So we've committed log, and it looks like, oh, modified hello world.c, taking note of the B6C hash. But say we want to make another change. So we make change to hello world.c, but it's not a very big change. We still have to add it. We still commit it the same way as we've done before. And we're going to call it remodified.c file. We've added the amend flag. If we take a look at the log after we commit now, you'll notice that this hash is different. It's because it has replaced the previous hash with a new one and has changed the file, or changed the message that we provided. So I thank you for your time, and I'll invite any questions at this point.